a walker. So I'm gonna have a hard time standing behind here, but I'll do the best I can. So I'm Adam Larson, and a little bit about me. I have 3 kids, 4 cats, somehow that manage a dog. I've been a dev for about 21 years, started professionally in 2004. I like to joke that I've held literally every role in a company possible, from unpaid intern to CEO, and pretty much everything in between. Most recently, as founder and CTO of Raylion, we built very heavily on top of LLMs, and I learned a ton, both about evaluating them, but also like how to actually build on top of them and provide business value. It was recently acquired, so I'm currently principal staff engineer at Intuit MailChimp. It's acquired 3 weeks ago, so it just happened. But I want to back up a little bit. So going back about maybe 18 months, do you guys remember on X, like every other post was, AI is going to take away all jobs from engineers. Some new model would come out, it's the best thing ever. Every YouTube video that came out was like the biggest hype thing ever. I kind of got sick of that personally, because like I would be like, man, you'd see, and actually I got a great example of this. Remember Llama 4? Like Llama 4 came out, like YouTube blew up, and it was like, this is the best model ever. And within minutes, reality starts to set in, and they're like, they're delaying it and nothing's happening. So that's really what I started doing on YouTube. Is I actually wanted to come up with a way to share the stuff that I was learning in the startup I was working on at the time, and really try to like be realistic. Like I did not see a path forward for like a full replacement for engineers, and I felt a lot of that was just marketing hype. I did not really see AI advancing to the level where like we were gonna be able to completely remove the human in the loop, and I felt like a lot of it was just way too much hype. But it is an incredible tool. Like I love AI coding assistants, and that's sort of the community that I built on GoToCoder, which is really focused around like using it effectively, but also knowing its limits and not overhyping the things that are actually happening. So, Llama 4 came out. I actually started doing what I'm about to talk about well before Llama 4, but typical evals would come, you've got like Terminal Bench, Sui Bench, there's a bunch of other ones out there that come out. A lot of them, back when I was starting this, were the most basic things that you would learn in like a first-year comp sci class. Like you would look at it as like, hey, write a function to do this particular thing. Very basic test. It was not indicative at all of what we were doing on a day-to-day basis. So they are improving now. I think Sui Bench is probably one of the better ones. Terminal Bench is also pretty decent. For example, here's like a Sui Bench example where they're actually taking a commit and they're actually trying to solve something that's actually, I would still say not at the complexity that I think we should be working at, but it is actually heading in the right direction now for evaluation. And I think it's important because we need to be able to at least somewhat measure, like be able to look at benchmarks and trust them to a certain degree, but we also need to understand like what they are measuring, and not every one of them is measuring what we think they are. Another one that we've got here is Terminal Bench. Terminal Bench, I would say, still errs on the side of like simplicity. And what I like to think about is like when we're actually working, especially in like big code bases, we're modifying anywhere from 1 to 20 files at times. Like we're working across business domains. We need it to gather good code base context. A lot of the things that you see like being evaled don't really do a good job at actually testing that. So this is just kind of like an example of something that I was working on recently. It's a fairly big thing. I've worked on it for like a day. It's 13 commits, 14 different files modified, 2,200 lines added some tests and all that stuff with it. You really are you're not working in these discrete patterns, and that's one of the flaws that I think we have with like really evaluating how these LLMs actually work. There's different metrics that we actually need to look at and try to understand. I got this like crazy AI generated roller coaster thing here, because that's what it feels like when you're working with AI. Like a lot of times you're just going with it. You're starting new context windows. You're doing all kinds of stuff with it. It isn't a straightforward path like a lot of the benchmarks that we see today. And that's when I ended up launching GoToEvals, which I'll talk through my philosophy here. But the idea behind this, I started this probably a year ago, and I've got to the point where my objective was, we have a new coding agent coming out every other day, and it was supposedly better in some way we've got a new model coming out every other day, and it's supposedly better in some way, but we have no real meaningful way that ever felt to me as a dev that was using it all the time, that it aligned with my usage, which is, everybody's stack's a little bit different, but I'm full stack. I was doing front-end work, I was doing back-end work, I was doing infrastructure work in AWS, I was doing machine learning stuff in Python. So I have a pretty wide breadth of things I need to work across, but none of them seemed like it actually was aligning to what the benchmarks were saying. So a lot of my initial tests in V1 were honestly built around things that I was working on. And I had this philosophy that instead of modifying one file or having maybe 2 or 3 files, I was going to have a minimum of 8 files touched, ideally more. So my version 1 of this, I'm still very naive, and I'll talk about the kind of the flaws with it in version 1. But it actually did start giving me something, and a lot of the community started resonating with it too, because they would align, or there might be slight disagreements, but it would align more with what the sentiment is of developers and what's happening with the standard benchmarks out there. But the goal really was, let's make the most complex thing we can, and let's do it in a way that we can now evaluate the quality of that at the end, which is incredibly difficult to do. So this is just a sample of some of the coding agents that I tested this last month. There's more. Even if you talk to someone here, there's the new one that came out from Gemini yesterday that will now need to be tested. Some of them are more updated than others. Some of them are better with certain models than others. So my original intention with version 1 of this was, hey, I want to use GLM 4.6. What is the best agent that goes with that? And there are some clear agents that actually do really well with that model compared to other ones based on my benchmarks. And I would say this is one of the challenges that actually starts to happen here, is the scale of testing all these things starts to get pretty astronomical. Because as you can see, some of this starts to actually become a little bit too manual, and I'll get into that in a little bit. These are the last models that I actually ran through. So you can see here, I would actually leave it up to the community a lot of times. I'd be like, hey, I'm only going to be able to commit to 5 this month because it costs a lot of money, it costs a lot of time. What are the 5 you want me to actually run through? These are the ones that were voted on. Grok Code Fast was one because I don't know if you saw, there's this crazy usage on OpenRouter with Grok Code Fast, and I've never felt that model was incredibly high score, but there was a lot of usage around it, but it did fare. The way that I ended up doing scoring in V1 is I had static code analysis. So what that means is simple things I would even do linting to make sure it followed what it did. But as part of the spec that was actually generated in the prompt, there were things you needed to use a particular library version. So there were checks that I'd actually manually build in static code analysis to make sure it's using the things that I tell it to use. I would also have a series of unit tests that if the AI did exactly what I told it to do, those would pass with 100%. And that would be, and those are very time consuming to actually make as well. And then if you use LLM as a judge on top of that, because we talked about that in a few talks today, sometimes AI can do things that'll pass a unit test, but it actually isn't doing a very good, it's doing things the wrong way. So it's very important to actually have that kind of check on it. And I learned a lot about writing LLM as a judge. In version 1, there was a lot of flaws in the way I did it. Version 2, what I ended up learning, AI is really good at yes/no questions. It's really bad at giving you a score. So if you say, hey, rank this on a score of 0 to 10, you're going to get wide variance. You really need to kind of think about your LLM as a judge as a series of yes/no questions, and then that comes together to be your final score. So sharing some learning lessons there. The other thing is you really do need good and bad examples. You need to be able to say, hey, this is what, for this particular thing, this is what a bad version of that looks like. This is what a good version of that looks like. And that allows it to actually score it much more effectively. And I really did think about this as the things on the left, they score the same every time you run it. The thing on the right, there's going to be variance in it. And that's just an unfortunate thing with AI that you have to deal with. The goal with that LLM as a judge prompt is to get that variance down as low as possible. And I got it down within a 5% percentage. So if I ran the same test through, 5 or 6 times, the range between the top and bottom score were within 5%. So I narrowed that in very well. Here's an example of like what version 1 actually was, where it actually was scoring on a scale of 0 to 4. And like I said, this was actually, it was decent, but I would say very flawed in my initial version of this, which then is what kind of led me to want to build a version 2, which I'll talk about. But it did do some things, in my opinion, very well. It was really good at measuring how well an agent and a model together was at completing a spec exactly as you kind of detailed it out. And it was really good at measuring an AI's ability to do instruction following. I learned that some models are lazy to where they will do up to a point and they would just stop. And then I've learned some other models would do way more work than they actually, you asked them to do. And it's really interesting because you start learning these personalities of models. Like, I didn't ask for those 5 markdown files, but yet, Claude 4.5 wanted to give them to me. And so you start trying to, so that's another flaw with this. Like, I never measured very well over-engineering, which I still think is something that should be measured, because you shouldn't do more than I ask you to do. Maybe other people will disagree with me on that. And this was really the first test, other than like ITER Polyglot, that really was trying to test the agent and the model performance in a way that allowed us to kind of be able to make an objective decision on what tool we actually wanted to use, or if a tool that came out that said it's better than everything else was actually better in any significant way. And to me, that was fun. Like, I had a ton of fun like working through that. But it did some things not so well. And you could go through my Discord history. There are people that would use like an obscure language like Apex, or it's not so obscure, but like Elixir. It might be scoring well on my test, but be absolutely atrocious at some language or framework that they're using. And that makes it incredibly hard, because that's another layer of testing that now needs to be done. Because what we've tested now is we know that in a bounds of certain technology, certain framework, certain code, this thing may be really good. But like, let's take it over here. Now we're using Elixir or PHP or Apex, and maybe it's not so good. So that was a big flaw with version 1. And then the AI harnesses increased it like so much faster than I could keep up with. I actually had to retire tests in the first 6 months. Like, I would put out a version, and none of them would be hit 100%. And within 6 months, a bunch of them were tapped out. It's like the cycle time and the updates that these agents had were just astronomical at the time that I was rolling this out. And it became very time consuming while building a company to try to keep up with that. And the other thing that I think is incredibly important, more so today than ever before, is code-based navigation and context gathering. Because now that AI is as good as it is, I can absolutely feel a difference from an AI that actually takes its time and gathers the context it needs to be able to make a good decision, versus an AI that like reads the first thing and then jumps to a conclusion. Like, there is a massive difference in my mind on the quality that you get out from whether it's a plan or whether it's actually an implementation. So version 1 did not do that. The other thing I learned, and this is a weird diagram, I know it's my beautiful art, but so back in my days when I was doing like machine learning, I'd build a model, I'd run it, I could get the same, you could run the same test over and over again, I'm gonna get the same number. With LLMs, there's so much variance to it. And one of the tests that I did, like that one that I showed you, might have 40 API calls out to the LLM. Little variances between each of those can start adding up to pretty significant differences. So if a decision is made like on loop 2, that might lead to a very major difference by the time you're far on to the end. So if you kind of think about this as the score across my evals, I might have 3 that are relatively close. I might have 1 that actually did kind of crappy. And I might have 1 that's just exceptionally good. So what I also struggled with was, how do you smooth that out in a way so that you actually are kind of normalizing those scores? Because it's a non-deterministic system. And there's variables that you can't take away. There's some variables you can control, but you just can't take away all of them. I can control the prompt that I go in, but I can't provide what Claude is doing in their server. I can't change what the LLM is doing as it's interpreting the tokens. So I just think it's very interesting that like you will see this more and more, and you're already kind of seeing it. As I was kind of learning this was probably about a year ago when I started kind of coming, like really starting to build the model of like the challenge of testing these things. Now what you see is you see things like Codex and Cursor allow you to be able to do like the same thing across 4 or 5 iterations, and then you can now pick the best one. And it honestly helps smooth out a lot of this from an engineering standpoint. Like if you want to see what GPT 5.1 is going to do versus Composer 1 versus something else, you can now run all of those in parallel and then pick the best one. I think it's a really interesting model, although it's still a little wonky in a lot of those systems, but I think it's probably more and more, they're trying to get around this problem here. Because if I take Claude 4.5 and I run it 5 times, I'm going to get 5 slightly different answers. One of them is most likely going to be better than the other. So version 2, so I'm on version 2 now. This is what I did. So I ended up adding more languages. So C++ got introduced, C# got introduced, Kotlin, Java, Rust got introduced. I also started actually using open source repos and my own private repos and snapshotting commits and actually doing feature additions or bug fixes in those as part of my evals. And I introduced one Unity 3D, because this was just a request that I got from a lot of people, is that apparently AI, I used to do game dev way back in the day, but apparently AI still struggles a lot with game dev. Like it can do some things really good, but others it struggles with. So I built a Unity 3D version of that. And then the test went from being 8 files minimum to 12 files minimum, and some of them go up to 20 to 25. So the complexity increased a lot. But think about this in terms of running it. Because this is my version 1, I could run them all in about 6-8 hours, bouncing around. Version 2, I'd have 4 computers running, 15 different agents is typically what I try to keep it at. Sometimes people try to push in more, or I'll get messages about it. And then 5 AI models. Typically, I would love to do more, but 5. And I run 20, I have 20 different evals that I have active. I typically have 3 or 4 that are in like test mode that I haven't kind of pulled up yet. And then if I want to run each of them 5 times, if I were to do all of those synchronously, one by one in a single computer, that would be 75,000 minutes. Like I literally couldn't do it in a month. So I have to try to run 40 to 50 of those simultaneously over a period of 24 hours. A lot of that I can automate, but there's a lot of those tools that I showed you, you literally can't. Like if you want to use the Cursor IDE or Kiro or Klein or Rue code, you have to actually put the text in there, hit the button. Sometimes there's an API error, so you have to interact with it. It's not as automatable as I would like that to be. So I've gotten to a point now where I think I've made it a bit too complex, to be honest, because it's hard for me to actually keep up with the evaluations that I want to do. But I've been thinking about a version 3, and I think we can do better. And part of the thing that I had been doing initially is, you kind of do a smoke test to make sure that the model is actually doing the tool calling right. And it was talked about in a previous talk about there's a bunch of different ways that tool calling happens. It's also a very frustrating thing to test. But there's a way to decouple that, and like we could very quickly test the ability of a model and an agent, how well they do tool calling, and automate the majority of that. We decouple that. And I've got prompt-based versus native. Someone else earlier was calling it virtual tool calling. I always call it prompt-based tool calling, which is like it's just in the text of the LLM and you have to parse it out. I don't know if there's actually an official name. And then the native tool calling, there's like 3 different formats for native tool calling that also are kind of annoying. The other thing is I think we can actually decouple code-based context gathering. There's probably some really cool testing that we can actually do to see how well, whether it's using some sort of system like Augment Code's using this in the cloud that kind of indexes your code base and allows it to search, or using something else. But there's probably some things that we can actually do to really measure how well an agent and a model does at getting the proper context for the problem before it starts coding, and I think that could also be done faster. So rather than me trying to do it all from beginning to end, I'm starting to think about like how can we break this up into individual like chunks of tests that ideally together give us the full picture. And then the final thing, I alluded to this before, but ideally, there's got to be a way for us to be able to manage and understand framework and language ability without having to write a full end-to-end test. Like we should be able to understand GLM 4.6 is bad at C++, but amazing at HTML, CSS. We should be able to quickly be able to evaluate that. I also want to, so this is kind of this is a tricky thing because I've actually had several companies reach out to me and offer to pay me pretty significant amount of money for access to my test or for me to work with them. And I've just never been a fan of that because in my mind, I didn't do any of this to make money. I did it for fun to try to help like the community understand what was good and what was working and what isn't working. And I worry about open sourcing all of it because I just have a sneaking feeling a lot of that will start getting gamed. And when that happens, it removes the validity of the test. And you can see that immediately with like Llama 4. It nailed all the benchmarks, but it didn't pass the vibe test. It didn't actually live up to expectations. But I do think there needs to be some part of like this framework that I've been thinking about that needs to be opened up to everyone. And there needs to be some subset of this that's private that can stay outside of like the gamified LLM game. It's the only way that I think this could scale. Because if you think about this problem, this sits outside of all the AI companies. Like Claude, they're going to want Claude Code or their models to be the best. OpenAI is going to want theirs. Cursor is going to want their agent to be the best. This sits outside of all of that. So no company is really going to want to ever fund like some big initiative like this. But I think it's important, as we're getting told this new thing's coming out, that we have some like ability to put checks and balances on these companies to be like, hey, yeah, Droid is awesome, but it isn't significantly better than what's already out there. So we shouldn't overhype it. We should just treat it for like what it is. And then I do think we can still keep the spec and functionality testing. I do think that's very important, especially with how good plan modes have gotten now. That if we can build like these specs that actually are completed, 80 to 90% of the way there, I think that's an amazing boost that we get as engineers. And one other thing that I spent way too much time on, way too much money on, is, someone alluded to this too earlier in a previous talk, but the Chinese models. I'm actually a huge fan of open source. I run a ton of open source models. My dream is to be able to like use a lot of those for everything I want to do. But what you'll find is, if you go to OpenRouter or to whoever's hosting the models, there's so much variance in the provider. So I actually built tooling around detecting the best providers with certain models based on how they're quantized, their default settings and stuff like that. And it put me in a situation where like, this is another variable that now we're dealing with. So when I'm running something like a quincoder, I'm now dealing with not only all the variants of the LLM, but I'm also dealing with the inference and the default settings and the temperature. So a lot of times I'd have to actually do initial work where I'm like, at temperature 0, it's awful. At temperature 0.7, it's all right, but at temperature 0.4, it's great. Like I have to kind of like tone in my own settings for it. And it makes it really hard for any person that isn't spending that time on there to be able to hear about a new model, go connect to it, and get some good results out of it. And I think that's gonna wrap it up here. Maybe just real quick, even Anthropic has trouble testing, because I don't know if you guys remember when Claude had that big degradation and everybody's like, man, Claude's definitely worse. I actually quit using Claude for a while because of it. This is just such a hard problem across the board. But you could check out go-to-evals.com. I will be posting some new stuff with like Gemini 3 on there soon. I want to see where that actually lands. But yeah, that's pretty much it.
Wow.